Hello, everybody, and welcome to my 24th day of my daily Leetcode streak, where I just go in raw and try to solve these problems as a relatively beginner programmer. So let's hop right into today's problem, which is Leetcode number 1498. It's called the number of subsequences that satisfy the given sum condition. It's a medium problem. The description seems relatively short, so I also see returnant modulo, so I'm guessing there's going to be some time constraints. So let's look at the problem. We're given an array of integers nums and an integer target. We need to return the non-empty subsequences of nums such that the sum of the min and max element in it is less than or equal to target. Since the answer may be too large, return it modulo 10 to the 9th plus 7. So with nums 3, 5, 6, and 7, and our target is 9, so the min and max element, the sum of the min and max element is less than or equal to target. Okay, 4. Okay, so you're returning the number of subsequences where you can have that. Interesting. Okay. Whew. Okay. So 3, and 5. 3, 5, 6. That's 1, 2, 3. 3 and 7 exceeds it, so 3, 3, 5, 3, 5, 6, 3, 6. Okay. I get that. Okay, second example. 3 is a subsequence. 3 is a subsequence. 3, 3, 6. And then go into the second one. 3, 6, 1. And this, why can't just 5 be a subsequence if both 3s are subsequences? Nums can have repeated numbers. There are 6 subsequences. 3, 3, 3, 3, 3, 6, sure, 3, 6, 3, 3, 6. Okay. Interesting. Result equals 0. We're going to start with, result equals 0. Mod equals don't make fun of me. Makes sense. 10 to the 9th plus 7. And then we're going to, at the end, return result mod. Makes sense. Okay. Let's try to understand this. We may need to go to the whiteboard. We'll see. I'm just confused why you can have 3, right? And you can also have another single 3. But why can you not have a single 5, a single 6, a single 7? I don't understand that. Okay, let's look at the last example, see if we're missing something. Okay, there's 12. We want to sort them. Really? Nums dot nums. Makes sense, I guess. Okay. We sort them. I mean, these are already sorted, I guess. That's probably why. Okay. Oh my god, it's like the last problem where you have to remember the original indices though, right? Because it's a subsequence. I don't like these problems. 2 pointers given an index I. Find max of j where... Okay. I guess that makes sense. Min element equals nums 0 and then max, or we can have just name them left and right, I guess. Left equals num 0, right equals nums of -1. No, it's not going to be -1. It's going to be, right? Find the max j where j is greater than I and nums I. Okay, once we find that, what? Count the number of subsequences. Okay. 3, 3, 5. 3, 5, 6. Equals 1 if should probably sort at the start. Result equals 1 if num 0 is less than target, less than or equal to target, else 0. And then let's actually put right equals 1. And then, or no. Let's put it at -1. And then, I think 2 pointers is while left is less than, while left is less than right. Right? Isn't that how it works? this like a binary search? Is it? Be like this. Yeah, this is mine. But considering them, they won't fill the condition because for one linked subsequences, min and max will be the same. Oh. Wow, yeah, that's true. It is a binary search, yeah. Okay, binary search. What, you have mid equals, what is it, left plus right divided by 2, and then you have I don't know. Could we... I don't understand how we can do binary search. Let's think about this. Okay, left, right. Well, left is less than, I believe it's less than or equal to right. Oh, I think I understand it. We want to figure out max can add. We want to figure out what the max element we can add is to, so that left plus right is less than or equal to target. Left plus right equals target. We find we can add all elements before the subsequence. So in this case, while left is less than or equal to right, so left is going to be 3, right's going to be 7. It's going to see, and mid is going to be 5. It's going to see if, what? It's going to see if mid, no. If left plus mid, if left plus mid is less than or equal to target. Then we want to left equals, or no, we want to have, how do we want to do this? So mid would be 5. My approach would be moving mid, but that's obviously not what you want to do in binary search. The max, what we want to have is mid be 6, right? But we don't want to move left, right? Or do we? Let's look at the hits again. Find the maximum j where j is greater than or equal to I. And nums I plus nums j is less than or equal to target. And then we count the number of subsequences. Then left equals mid plus 1. Else right equals mid minus 1. I just want to see print left. Our output is 6, and that's exactly what we want, because 3 plus 6 3 plus 6 is the max one where left plus mid is less than or equal to target. This is 10. I believe that's what we want as well. Yeah, because the max is 6 here. This is 7. Okay. I think that's what we want, yeah. Now that we have the max elements, now the third hint was just count the number of subsequences. I feel like I'm missing something though. So now that we have that, I think I need to look at a solution. Oh my god, I don't enjoy these pictures really. Okay. N equals length nums. Power equals what? I'm so confused. has to be nums left, right? So n equals length of nums. Oh, but I'm not doing this right at all. I'm not doing this right at all. So power equals 1. What is this? You're filling an array full of 1s of the length n. For what reason? For I in range, you're starting at the second element going to the last. Power I equals power I minus 1 times 2 modulo mod. Modulo mod. And you're, no. So while left is less than equal to right, you're not even finding a mid? Yeah, I'm doing this completely wrong. Yeah. If nums left plus nums right is less than or equal to target, result equals result plus power right minus left mod left plus equals 1 else right minus equals 1. Okay, let's figure out what's happening here. Power I equals power, so the previous power times 2 modulo mod. Let's see the explanation. Quickly determine the number of valid subsequences in any window. For each window, if nums left plus nums right is less than equal to target, all subsequences are valid. Add 2 to the right minus left to result. Can we have a better answer or a better explanation, please? On the second part, so just C++. Okay. I feel like this is a hard medium. You have to be very good with binary search, and I guess, yeah. I'm not leaving until I understand the solution, though. I guess we look at the editorial. Nope. Good, got it. Chat, can you help me? My one and only ChatGPT tutor. What is it, 1490 something, 98? Please, chat. Even a number, sure, yeah. Okay, so I'm power 2, pre-compute powers of 2 for I in range 1 to n power 2. It's the last power of 2 times 2. Why'd you go mad? Yeah, sure. Compute powers of 2. Okay, you have result left, right. This is basically the solution that was posted. While left is less than or equal to right. If num's left plus num's right is less than or equal to target. So you're putting left and right at the two ends of the array. If it's valid, then we have result plus equals powers 2 right minus left. Instead of explicit binary search, we use a two-pointer technique, which behaves similarly and more efficient. Okay. Why are powers of 2 used in this? You fix an element nums I as the min of a subsequences. Then you look for the max such that, sure, that means all elements between I and j are eligible. Now from the range I plus 1 to j, each element can either be included in a sequence or excluded. Because each of the j minus I elements has two choices, included or not. So you can generate because to okay. Yeah, let's see a example. So I equals 0. Find the largest j such that so left and right are going to be 3 and 7, right? j equals 2, elements between I and j, 3, 5, 6, subsequences with 3 fixed as min. It's 2 to the j minus I. 2 to the 2 equals 4. Can you go my example where nums equals 4, 4, 4, 4, 4, 4, 4, and target equals 100. Already sorted, we'll use the 2-pointer method. Yep. This means all values between left and right can be valid subsequences where nums left is the min, any subset. 2 to the right minus left, right is 3. So 8. Oh, is it 4? Now we add 8 to our result and move left. Left equals 1. Repeat. Oh, interesting. Oh, it's right minus equals. For any set of n elements, the number of subsets is... For each element, you have 2 choices, include it or exclude it. So with n elements, that's 2 times 2 times 2. You fix one element as the min of your subsequences. You find the farthest element such that, yes. So any, okay. Include or not in the subsequences. Nope. Not an easy problem. Not an easy problem at all. Pre-compute the powers of 2. That's a good question to ask as well. Okay, sure, but Yeah, this is what I was basically asking. There's nothing but it has useful properties. It's a prime number. Okay. Specifically, it's a prime number though. Interesting. Uh-oh, it's raining hard outside. So this starts at 2, 7. I minus 1, so yeah, I understand that. I understand the pre-computation of the powers of 2. Now, 2 pointers, you start at each end like the binary search, but you don't compute the midpoint. Instead, you see if the left and right pointers add up to less than or equal to target. If they do, then you add. What? You don't even add it to result, you just. Oh. Interesting. Result equals result plus. Does this work as well though? No, it doesn't work because. Yeah. It does? No, it doesn't. Because you're using the mod. It's only for large numbers like this. Yeah, I'm saying. Specifically for the mod, you need the result in the parentheses. And then if this works, if the endpoints work, great. Now once you compute 2 to the however long the sequence is, minus 1, then you move your left pointer 1, and you do the same thing. But now since left plus right is greater than target, you want to move right to the. You want to move right, your right pointer 1 left. Now left equals 5, right equals 6. That's still greater than target. So now, yeah, the only subsequences are this, and that's 2 to the. What is that? 2 to the 3? 2 to the 3? Or what? Oh no, because 3, that's greater than target, so actually it would be here. Which is 2 to the 2, which is 4. Interesting. Okay. Right equals. Left equals right. Okay. Still a little bit having trouble grasping the 2 to the right minus left, but yeah, this is basically just saying add 2 to the right minus left to result. I'd say this is definitely a harder medium problem for sure. Because you have to know specifically this for the number of subsequences. And then you move left one, yeah. This might be like hindsight bias, or I think that's right, but I think this makes sense to me. Should I try doing it by myself? I think I could do it. Let's try it. Oh, don't get rid of the whole thing. Okay. Alrighty. So result equals this. No, result equals. Oh, I'm already forgetting. Mod equals 10 to the 9 plus 7. Okay, power of 2 equals 1. Oh my god. 1 times n, forgot that, n equals length of nums, and then for I in range 1 to the n, 1n, power of 2 equals, or power of 2, I equals power of 2i minus 1 times 2, and then that, all of that taken to the modulo of mod, right? And then I want to make sure that's right. One, two, four, 8. Perfect. So those are the powers of 2. Now result equals 0. Oh yeah. Left, right equals 0. And then n. N minus 1. And then while left is less than or equal to right. I know I'm missing something up here, but I bet I'll come across it when I try to do this solution. So if nums left plus nums right is less than or equal to target, then we want to add this to our result, right? Result equals result plus 2 power, oh no, power 2. Power of 2, right minus left. And then all of that modulo mod. And then we want to left plus equals 1. Else right minus equals 1. Turn result. Okay, what am I missing? I'm definitely missing something, yeah. Okay, I'm missing something. What is it? What did I not do? Oh, I need to sort the numbers, obviously. Oh, that was stupid. Cool. Yeah. Once you understand that the number of valid subsequences when the outer left and right are less than the sum of those are less than or equal to target. Once you realize the number of valid subsequences are 2 to the n, or 2 to the right minus left, that makes it a lot easier, and I did not know that before this problem. I saw binary search in these other, and I computed the midpoint, and it just threw me off. But definitely learned something here. I think Chad is a better tutor than 99% of these people on Leetcode solution. It does look a lot like binary search, but I think a staple of binary search is that it computes the midpoint every iteration. But yeah, cool solution. A little bit of combinatorics in there. Another day, another day, more learning. Yeah. Cool. Well, that's it for this video. I don't think I'm going to be posting probably for the next week as I'm going on vacation. I'm probably still going to keep the streak alive on my laptop, but I won't be able to record. But I'll make sure to record as soon as I get back for all of my loyal followers out there. I'm sure you're super worried about me not posting, but just a heads up. Peace out, guys. See you in a week.